Yeah, straps, we got them 2 foot on center here. So all our buildings are built on concrete pilings that are poured on site, and we wet set an engineered bracket to hold the post. These brackets, they vary between 1 foot to 2 feet tall depending on the size of the building, and we use structural screws and sometimes through bolts depending on the engineering requirements to bolt the posts into these brackets, and it makes a very solid connection. Most of our buildings are built with pressure treated posts or fir posts, either 6x6 or 8x8, depending on engineering requirements, which depends on the size of the building, snow loads, etc. The posts are on 8-foot center, and then on top of those posts, we do typically a 3-ply 2x12 beam. Smaller buildings, maybe 2x10 or 2x8, but a 3-ply 2x12 beam is pretty standard on, say, a 30x50, 40x60 size building. Those are attached to the post with structural screws, and then the trusses bear on top of that beam, and they are attached to the top of the beam with hurricane ties, they're called, which hold the trusses down, so there's any uplift, they're connected to the beam, then the beam's attached to the posts, and the posts are bolted to the piling foundation with the special engineered brackets. Yeah, so all our buildings, we do 2x6 strapping, as you can see here behind me, 2 foot on center. So 2 foot from the top of one to the top of the next. And our posts are 8 foot on center. So that's why we go with the 2x6 strapping, because it gives it a little extra strength that way. Right here behind me, we've got a engineered shear wall in this building. So that engineered shear wall prevents this wall from racking, gives you some extra strength there. And that depends on the size of your building. Smaller buildings don't necessarily need them, but something like this one that's 2,400 square feet, our engineer requires these shear walls in different locations just to give the building some stability so it doesn't rack. Cool.